Hi everyone, in this video we will see how to find probabilities for a geometric distribution using TI84 plus or TI84 or TI83. They all have similar functionalities. So to calculate the probabilities for geometric distribution, you would need to access this distribution menu. So if you hit second vars, that'll give you all the options for distribution, and geometric is all the way at the bottom of the list. So you could scroll down, but if you hit the up arrow key, that will bring you to the bottom of the list, and what we need is options E and F, geometpdf and geometcdf. PDF you use when you're looking for the exact value for a probability, and CDF when you're using for cumulative values. So you have some direction going on, as in less than or equal to a certain value, greater than a certain value, and so on. So we'll take a closer look at both of them in an example. But first, real quickly, let's recap what geometric distribution is. So a random variable x has a geometric distribution if it has values with number of independent trials that you have until you get the first success. So you could have many failures until you get that first success. So x could have values from 1, 2, 3, and so on, and up to maybe a very large value for failures. Maybe you don't get a success till a very, very long time. So that's what the distribution is. Notation for random variable is G with the probability P of success, G for geometric, and then the probability of failure is given by 1 minus the P, such that P plus Q would equal 1. The idea is, the goal is that the trials are repeated until the very first success. So you have failure, maybe many times, and once you get that success, you stop. And for those of you interested in calculating other statistics about geometric distribution, the mean is given by 1 over the P, probability of success, and standard deviation is the square root of the mean times the mean minus the 1. So now let's take a look at an example to follow on the calculator. So we have this example from OpenStack's textbook. Assume that the probability of a defective computer component is 0.02. Components are randomly selected. Find the probability that the first defect is caused by the 7th component, and then find the probability that at most 7 components were tested before the first defect. So we are repeating it until we hit the first defective computer component, and the probability of doing that is 0.02. And so that makes it a geometric distribution, and that's when we stop. So P is at 0.02, and for the first problem, we need to find at x equals 7. So it's an exact value. Let's go to a calculator. And we are already at the geometric function screen. Its exact value, we need to select PDF. So scroll up, hit enter, and it's pretty straightforward. So type in the probability, 0.02. Oops, that didn't go well. And x value was 7. So come down, type in 7, come down, select paste, enter, and on the main screen hit enter again, and you get the result of 0.0177 for the first 4 decimals. So this says that the probability that the first defect is caused by the 7th component tested will be 0.0177, or roughly 2%. And let's take a look at the second part. So find the probability that at most 7 components were tested before you found the first defect. So at most, that means you're looking for probability for random variable x being less than or equal to 7. Let's go to a calculator, and we need to get back to the geometric distribution functions. So second vars. Scroll up, and this had direction. So we're looking for x less than or equal to 7 versus exact value of x equaling 7. So we do select CDF, and the values stay the same, 0.02 for probability. X value is still 7, but the difference is this time you're looking for all the values leading up to 7. So it's cumulatively for probability of x equals 1, x equals 2, and so on, all the way up to x equaling 7. Hit paste, enter, and then enter again, and you get 0.13187. So roughly 13.2% is the probability that at most 7 components were tested before the first defect was found. And that's how you calculate probabilities for a geometric distribution using TI84.